Hello students, I am Dr. Tanmoy Vishwas. I welcome you all in my channel Chemistry, the Mystery of Molecules. I hope you all are fine. I know the world is going through a crisis tension, but I suggest please keep patience. Government agencies, medical personnel, they are trying their best. Please cooperate with them. This problem will be eliminated. So since we all are in home, it is better to utilize the time. So let's study this topic for today's discussion. So today we will discuss about the Michael addition and dialkylation of the active methylene compound. Okay. So I have given a little brief about this topic in the previous video. Previous video means the basic concept and mechanism of Michael addition. But I thought after completely making this video, I realized that I should give you a better understanding. That is not enough. So I decided to make the dedicated video on this. So we will learn mainly this topic and corresponding electrosynthetic approach and utilization of this compound, little details. Okay. So before going to details, I have a small request. If you really like my teaching, please help my channel for its growth. Okay. So let's start. As you can see, this is Michael addition, means it is a software nucleophile which is generated by the reaction of KOH and this active methylene compound, and the nucleophile is actually this is diethyl malonate. Its name is diethyl malonate. I suggest you please keep these names also in mind. In short, it is abbreviated as DEM, diethyl malonate. Okay. So this is actually carbon nucleophile, or actually it's a softer nucleophile. Okay. So consequently it will attack here. And another thing, see, this attack, it is our target. That's why see this is good because bulkness factor is also less here. Okay. So it will attack and do the reaction. Before going to details, this is also named as methyl vinyl ketone. Methyl vinyl ketone, or in short it is named as MVK. Keep it in mind, it's a very unique substrate. See, this is very less bulky, very reactive. Reaction happens here. And how this could be prepared? This could be prepared by the reaction of acetone plus formaldehyde. You know formaldehyde is a superaldehyde. Why? Because the bulkness is minimum and no plus R effect, plus I effect, because hydrogen, small atom as well as no plus I effect. So very high electron deficient means strong electrophilic. So this anion generated from the acetone reactor ultimately result in this compound. Now question, what happens when it attacks? So this retrosynthesis, I believe you must make a habit. I know sometimes you may feel why sir it is needed, but I believe if you want to learn organic chemistry by heart, you have to learn this process. You have to be accustomed. I have done and I got the benefit. So I suggest you please try. So this it is expected to attack here, it will come, it will open. So it will result in, this is the CH CO2ET, this is the CO2ET. Okay, and next is this is the CH2, after that this, and I am not writing details mechanism. I have explained in the previous video, please visit. I want to make it unnecessarily long. So this is the product of our Michael addition. First. Now, interesting thing, if you use excess base, why I am telling? Because first step of the reaction is this one. Okay. Excess base, first point, and second, excess MVK. If you use excess base and excess methyl vinyl ketone, why? See, first of all, this reaction will happen. Second, this is also active methylene group. So it will prefer to remain in the corresponding anionic form. So what do I mean? This proton will be abstracted and it will remain in this, and this negative charge is resonance stabilized by these two groups, like the first case here. Okay, so this is the thing. Now don't be confused. This is 1, 2, 3, 4. Intramolecular not possible. So question, if this is in excess, another thing, see, that's why this is taken. It is a principle of design, means interesting point of design. Very reactive substance. Although you think it was a 2-degree carbon previously, it was a 2-degree carbon. Right now it's a tertiary nucleophile, bulky. I agree, but the electrophile is less bulky, so reaction can happen very easily. Fine. So what is the product? So first of all, it will react and ultimately, see this side one, this part, 2 carbon, carbonyl methylene, 2 carbon, carbonyl methylene. Second one another possible. So second alkylation. Why reaction will stop here? Because no proton is there, removable proton, acidic proton. So reaction will stop here. Fine. So this is the interesting point. First of all, excess base, little drastic condition, and under this is a very less bulky means alpha beta unsaturated carbonyl compound. Okay, so this is the main discussion of this topic. Now one interesting point. Interesting point is that what is the utility of this compound? See, this is actually 1, 2, 3, 4, 5, 6, 7. So this is dialkylation resulted in 1,7-dicarbonyl compound preparation. Okay, so this is one interesting point. Now you can do other reaction using this. By the way, if you think that this group is creating problem for you, this is also a carbonyl, this is also a carbonyl, so if you do some reaction, there may be an interference, you have a solution for that. What? So you can convert this is a ketone carbonyl, so you can convert them easily into acetals. I have already described this acetal chemistry in my previous video. If you have any difficulty in understanding, please visit it. Okay, and acetals are stable in base, unstable in acid. So if we do reaction under basic condition like reduction using lithium aluminium hydride, so what it will done? This ester will be converted into the corresponding alcohol. So this will be CH2OH. This is also CH2OH. Then there is no problem. And now after that, what you can do? You can hydrolyze this in presence of acid and this to get back your parent ketone. Okay. So I guess it may not confuse. So you can get in this way your parent ketone. This. So this is no problem. Purely 1,7-dicarbonyl compound. So this is the interesting thing of this. So what is the background possible? Important point is that active methylene compound contains, it's a methylene, means 2 proton. So 2 proton could be replaced by 2 group during the Michael addition. So this is the interesting point. So this is the overall discussion for today. Thank you everyone for watching this video. If you really like my teaching, I request you please help my channel to grow. First of all, subscribe my channel Chemistry the Mystery of Molecule, and please press the bell icon to get the notification of every single video I upload, because I prefer to upload on a regular basis. So it will be helpful if you read the video on a regular basis, and for that you need to get the notification of all videos. Secondly, share this video among your friends so that others will be benefited, and most importantly, please like the video and make some good comment. It creates lots of satisfaction. And if you think some modification is suggestion essential, please mention in the comment box. I shall try accordingly. So thank you again. Stay happy, stay blessed. See you in my next video.